To understand a solar eclipse, we have to start with the sheer dominance of the sun. It contains over 99% of all the mass in our solar system, making the Earth and Moon look like minuscule specks of dust by comparison. This celestial model illustrates an incredible mathematical coincidence known as the 400 rule. The sun's diameter is 400 times larger than the moon, but sits 400 times further away. Because of this exact ratio, from the ground, these vastly different bodies appear the same size. They overlap with surgical precision. This means the moon doesn't cast a broad blanket of darkness over our entire planet. Instead, it projects a tiny, highly concentrated shadow that moves across the surface of the Earth at incredible speeds. Witnessing this event requires absolute geographic precision. Because the shadow is so small and moves so quickly, you can't just wait for it to arrive. You have to chase it. This diagram shows the mechanics of that shadow, which is split into two tiers. The deep, sharp inner core is called the umbra. If you stand inside this specific circle, 100% of the sun's light is blocked. In August 2026, the umbra made its first touchdown in the remote icy waters off the coast of Greenland. Some of the first observers stood along coastal waters, experiencing 2 minutes of darkness in the middle of the day. From there, the shadow raced eastward across the ocean, sweeping toward the massive crowds gathered in Reykjavik, Iceland. Standing inside that narrow umbra is the only way to experience a true mechanical blackout, an experience that separates these few observers from the rest of the hemisphere. This map illustrates the second tier of the shadow, known as the penumbra. It is vastly larger and more diffuse, covering a massive geographic footprint across the northern hemisphere. Millions of people spread out from Canada to northwestern Africa were in this zone. From their perspective, the moon merely appeared to take a bite out of the sun. This partial alignment was enough to pause daily life across several countries. In Maine, observers watched as clouds drifted over the International Space Station, while in Austria, a soccer match was momentarily delayed so the crowd could look up. Without specialized equipment, urban observers got creative. In London, people used kitchen colanders to project thousands of tiny crescent shadows onto the pavement. In major European cities, millions of people mobilized at famous landmarks, gathering to test out their protective eyewear and share the view. While the penumbra offers a less dramatic scientific event than the total blackout of the umbra, its massive scale creates a much wider shared experience for those on the ground. Eventually, the path of totality crossed the ocean and made its final continental strike against mainland Spain. In towns like Lodoso, viewers caught the diamond ring effect, a single, brilliant burst of light that flashes just before the moon completely covers the sun. The 2026 eclipse carried a unique mechanical quirk. Because of the Earth's rotation, the shadow reached Spain at the exact moment of dusk. This created a sunset eclipse, where a glowing, crescent-shaped sun sank directly below the horizon. The precise timing of the Earth's rotation transformed a standard eclipse into an exceptionally rare atmospheric climax. The moon's shadow only offers about 2 minutes of darkness in any one location, yet humanity has built permanent, heavy infrastructure specifically to study it. High in the French Pyrenees, professional astronomers at the Pic du Midi Observatory prepared advanced equipment to capture data from the sun's outer atmosphere. But participation didn't require high-altitude science. In small Spanish towns, people laid inside portable planetariums or simply stood in public parks with cardboard glasses. Despite the massive disparity in technology and geography, every single observer was pointed in the same direction, tracking the exact same celestial alignment. As the shadows slipped off the Earth, the light returned to Spain and the skies returned to normal. For a few minutes, this brief alignment synchronized the behavior of millions across continents. It compelled people who would otherwise never meet to perform the exact same action at the exact same moment. A total solar eclipse remains one of the few natural phenomena that forces us to stop looking at one another, look up, and collectively acknowledge our shared position in the solar system.